Greetings. In this tutorial, I'll be going over a few basics of Super Nintendo and Super Famicom ROM hacking, including the use of a hex editor, understanding pointers, and some simple debugging. Some of you who might be watching are new to the ROM hacking scene. Just keep in mind that this isn't the type of hacking you've seen in the movies. People who hack games in general aren't interested in infiltrating networks or stealing personal information. We certainly don't do it as fast as the people in the movies. But generally, ROM hackers have a passion for learning and discovery. In our case, we enjoy picking apart old video games and understanding the ins and outs of old hardware and bending them to our will. If you are new to ROM hacking, or if you're used to hacking other consoles, the same principles should apply, but I'll also go over some of the basics. You'll want to keep in mind that this tutorial covers hacking a single game, Wizardry Gaiden 4, but this same information will apply to most ROM hacking efforts. Okay. So before we get started, let's make sure we have our environment set up and ready to go. Just go ahead and take a look now down at the video description below for a list of the required files. You may notice that I've packaged together a bunch of tools that we'll use in our tutorial. This includes the Wizardry Gaiden 4 English Beta Patch, Beat, which is a BPS patcher that just will patch our original ROM to the English version, HXD, which is a hex editor, Lunar Address, which, as you'll find out, we'll use for converting addresses, regular PC addresses to Super Nintendo addresses, and the program BSNES-Plus. Now that's a debugger, but it's also an emulator for Super Nintendo, Super Famicom games. You'll also need a copy of the original Wizardry Gaiden 4 ROM. We'll need to extract that wherever we're going to be doing our work, and you'll want to extract all of the pointer tutorial file pack into the same folder. You'll also need a notebook or a piece of paper, or you can use Notepad like me. I use Notepad all the time to make notes. And I've included links to all of the tools below. So if you have any questions about how those things work, you can take a look there first. But I guess that's it. Let's get started setting up our environment. Okay. So here is pretty much all the files that came in the pointer tutorial package. You'll find Lunar Address, BSNES-Plus, Beat, HXD, and the Wizardry Gaiden 4 patch. You'll need to find and download the original Wizardry Gaiden 4 ROM file. We'll be using that as well. So since we're all set up here, first thing we want to do is patch the Wizardry Gaiden 4 ROM. To do that, let's go ahead and open up Beat. And I'm going to just start that up. Hit Apply Patch. Just wants us to choose the patch file. I put this all on the desktop, so it's a little bit easier for you to find all the files, and you don't have to be flipping through a bunch of windows. Go ahead and click on that. Next, it wants the original ROM. So go ahead and click on your original Wizardry Gaiden for ROM. Hit open. Next, it wants the output file. And this patcher is a little bit incomplete. So it's not going to do a lot of work for you. So just type in wgiv space en.sfc. And I use the SFC file extension because I like it better than a lot of the others that are out there for Super Nintendo and Super Famicom ROMs. And that's the only reason. Okay, go ahead, hit save. Patch was successful. Now we can close this, and we'll close that window. Now we've got the new ROM file. We'll put that right next to the old one, or the original one. All right, the next thing that we're going to do is open up the ROM just to make sure we patched okay. Pretty sure we did, but we'll just test it out. So we'll open up BSNES-Plus, and I'm going to change the size of this window. Get it out of the way a little bit. And you can start up the ROM just by clicking and dragging it on there. You can also associate that file type with BSNES if it makes it easier for you to start it up and test. But we'll just click and drag it onto the executable, and it'll start it up for us. Now I have this going super fast, and I've already muted the audio output. So there we go. Looks like it's working okay. Now, before we get started, I just wanted to go ahead and show you what we'll be hacking in this game. So I'll go into the item shop, and I'll just pick someone random to shop. Now, originally when this was hacked, the person hacking it didn't have a full understanding of pointers and how to use those to expand the amount of text that can be displayed in certain locations. So this is mainly what we'll be looking at during this video, this screen right here, where it has buy, sell, uncurse, identify, pull gold, and buy. Now, it only looks like this because they didn't have enough space to say everything that they wanted to say. So that's what we'll be doing, is expanding this by changing the pointers. Okay. Well, quickly, I'm going to go over decimal notation versus hexadecimal notation. I've got here on the screen a quick Word document that I put together that just shows a comparison between decimal, hexadecimal, and binary. Decimal it has 10 digits, so 0 to 9 are the digits in decimal. Now compare that to hexadecimal, where we have 16 digits. We count from 0 to F. As you can see on the left in the decimal column, that corresponds to 15, or technically 16 if we're counting 0 as 1. But that's how it converts over. All right. So we'll quickly just go over binary. Just know that these are the binary equivalents. Binary is sometimes used at a low level as flags or on and off for different features, and that converts into hexadecimal. That's really all you need to know. Just know that 8 bits make a byte. FF as a byte equals 255, or if you're not counting 0, 256. So that's all you need to know about binary. So the next question that you might be asking yourself is, what is a pointer? A pointer points to data, and that's about as simple as I can put it. Essentially, when you're working in any lower level programming language, you have ways of pointing the code towards the data that you need to grab. In our example, what we'll be working on is finding the pointer that points to the text in Wizardry Gaiden 4 for the buy, sell, uncurse, identify, pull gold, and leave options in the menu. Right now, the pointer may be restricting how much room is available for all of those words to be spelled out. So the first pointer is pointing to buy, and the next one is pointing to sell, but doesn't leave enough room to spell out full word buy. Another way of saying that, so the code essentially says, give me the data for the word on the menu. And the pointer is like, hey man, it's over there. That's a really simple way of putting it. A little bit more complicated than that, but that's really all you need to know in order to successfully modify a pointer. So if you found the data, you just have to find the pointer for that data, and you can change where it's pointing to. First thing I want you to notice is off to the left side of the screen, you have something called an offset. Next to that, you have a bunch of hexadecimal numbers all next to each other. And this is our data in the ROM. Now, when we're looking for data in the ROM, you can just scroll down the side. And if you get lucky, and you will get lucky with this game, everything is stored in a familiar format. Most games don't store the text this way, where you can just see it on the right side of the screen. So this is a good game for people who are just starting out. As you can see, each of these letters maps to a hexadecimal number. Now, since we are so lucky that all of our text is mapping up to a standard format, we can easily search for text in this ROM. And that's usually what you want to do when you're trying to locate a pointer for text. First, you have to know where the text is at. And then the pointer usually comes somewhere before that. Not always, but a lot of times it'll be right before the text that you want. Well, right before a big block of text. So in this example right here, this is probably pointer information somewhere right here. I'm not saying it is, it's just more than likely that could be some pointer information for that text below, telling the program where to find text. Okay. So let's go ahead and search for a word that we know is in that menu. I'll move this over here, have this going here. So we've got buy, which is BY. I'm just going to hit Control F to search for a text string. We'll do BY. We know it's case sensitive. And I'll search all directions since I don't know if I had passed the text already. Now that doesn't look like that's the text that I'm looking for. It just happens to have the same combination of characters there. So I'm just going to hit F3 to search again. Now we're getting closer. If we see word buy, so we'll just keep searching. And it looks like our third search, and we found the menu text we're looking for. We're in luck. Everything is right next to each other. We have BYSL for sell, uncurse, identify, pull gold, buy. Now, what we want to do is locate the pointer for this text. in our case, the pointer table is right directly before this. I believe it starts right here. Most people can't easily see that this is a pointer table. So how did I know that that was a pointer table? Well, first off, let's look at the offset that the word BY starts at. And I'm just going to put the cursor right there before the BY. And you'll see at the bottom of the screen it says offset 946C4. Now what you'll want to do for this is go ahead and open up the Lunar Address tool that was included. Just open up that folder and run the program. You'll get this screen, or a window that looks like this. I'm going to shift things around a little bit, give me some more room. Now, Lunar Address is used for converting offset information that you'll see in a hex editor to something that's actually used in the Super Nintendo code, and it's how the processor is actually addressing the information. It's how it's mapped in memory. And that sounds more complicated than it is. I assure you it's just a simple calculation to find out what the Super Nintendo is addressing a certain offset as. So let's go ahead and convert the PC offset to a Super Nintendo low ROM address. To do that, we just look at the offset that we identified before, 946C4. We'll just type that in here, 946C4. And if you want to calculate this yourself, I'll give that information in the description. But it's a simple calculation to find out what the low ROM address is. Now we're only concerned with the last 4 digits of the low ROM address. The first 2 digits is what we call the bank, or the bank byte. We're not going to concern ourselves with this because that bank is the same as the bank for the address of where the pointer table is stored, which you can just assume right there that code already knows what bank that it's in. And it is just using 2-byte addressing mode. Okay, hope that made sense. Probably not. So when we're looking for a pointer in the actual ROM file, we'll be looking in little endian style, which means the little end comes first. So instead of searching for C6, C4, we'll be searching for C4, C6. And as you can see, that particular string of bytes is right there. Now you may say, well, that could happen anywhere in the ROM. And you're right. And in this case, the pointer table is actually a little bit different than most pointer tables in that it's actually storing the screen positioning offsets along with the pointer information. So these 2 bytes right before that pointer is actually referring to a position on screen to print that text. But it's in relation to the position of the window. So we're actually looking at line 0, position 1 on the x-axis from the side of the window is where it's going to position by. As you can tell over here, it's over about 1 tile from where the window starts. And I only figured that out by just playing around with changing values. So sometimes that's what happens. And we're not really concerned with this. We're mainly concerned with the pointers that are right here. So we see that's the first one. The second pointer, just a couple more bytes away, says C7, C6. Now let's see if that's true. Let's see if SL actually is C7. And now you don't even have to convert that to a low ROM address to see that that is at offset C7. So makes it pretty easy on us. We're able to tell, okay, well, yeah, we're looking at a pointer table. All right. So now we found the pointer table. We know where the text is for the menu. So how do we change that without breaking everything horribly? Now, in most cases, you'll have what's called a terminating byte between each text string. In this game, it's using a null byte, which is just 0 in between each one. And all that does is it signals the end of that string, whatever was referenced. So if we wanted to type in the full word by, then we would need to replace that byte. Again, as you can see, I typed it in right at the end of by. And we're just going to put an S here for now. And since we moved over that null pointer, or that null byte, it's actually going to signal right away to the game that there's no text on that second line. And that's because we haven't changed the pointer. So let's go ahead and save our ROM. And I'm going to go ahead and reload. It's a nice feature of this particular emulator when you're making changes like this. And we'll go back in. I have to add members to my party again. And let's shop. And you can see we've got our full buy, but we don't have anything there because where this is pointing is directly at the end of string byte. So it's like the text is here, there's no text here. So if we want to change that, say we want to move cell somewhere else, we can do that. But before we do anything else, let's make a note of the location of the pointer table and the location of our text. So I'm just going to make a note real quick for me, just so I can find it easy here in a second when I go looking for some free space to put our text. Because as you can see, there's a lot of information in here, and it doesn't look like any of it's going unused. And we have a limited window in which we can move the text, since we're dealing with staying within the same bank. As you may remember, we have to be within bank 12 because that's where the code is expecting the data to be. So we're actually going to be within there's quite a range where we can put the data. We just have to see if there's any room. Now, what I usually do in this, when this happens, when there's no room readily available right in the immediate vicinity, is I'll go up a little bit and see if I can find something. And the first thing that I noticed when I scrolled up here is I see some text that's used twice, and it looks like it's used by two different pointers. We've got cell and item, and then an end of string byte, 0 there, and then it has cell and item again. Now this is a horribly efficient way of storing information in the ROM, and for us that's very fortuitous, because now we can repoint the information to just one of these. We can repoint the pointers to just the first instance of this. And we can actually shorten this up a little bit, because we've got this byte right here, 0A, that's an end of line byte. We've got 2 spaces here, and that's just free space for us to use later for other things. So I'm going to move that end of line byte up and just type the rest of it. Item. And I'm going to end it right there. And I'm just going to fill this with zeros up until there, because I still need to find where the pointers are for these particular strings. Now, if you'll remember before, in order to figure out where the pointer is at, what we can do is just put our cursor right at the beginning of the string, and it's usually right after an end of text byte, or a null byte, as it usually is. And you just put your cursor there, offset 944AF. And that corresponds to 12C4AF. So let's search for that pointer. First, I'm going to quickly write down the address that we're at right now. 944AF. Just so we can jump back down to it if we need to. So the pointer we're looking for is actually AFC4, because we're looking for the pointer in little endian encoding, as I explained earlier. So let's go ahead and hit Control F, and we'll look for hex values, and we'll find AFC4. And I'm going to hit OK. Now, and actually, before I do that, let's go back to where we were. Nine, four, four, eight. Before we do that, we need to know the address of the other one as well, so that we can identify the pointer table. A lot of times, information in pointer tables, the pointers and the data don't correspond directly. Like, the pointer might point to one one area of the ROM, and then it could point way up here, and then point down here, and then point somewhere else before it actually points back to the next physical piece of data in the ROM. So you have to keep that in mind when you're looking for pointers. Sometimes it's not so straightforward. Most of the time it is, though. In this case, it's not. So I just needed to know that other number for the offset. We're actually looking for C3. And just so we can see that we're pointing at the other location, I'm going to put an extra word in here. And I'll put poop, because that's always the first thing that comes to my mind. I'm weird like that. Now remember, we're searching for AFC4, which is what we converted that first position to. AFC4 in Little Endian. And we're also looking for C3, C4. Control F. AFC4. And here's the first one we come upon. And it looks like this one does have AFC4. And then a few bytes down, we've got C3, C4. But the way that this is laid out, I'm betting that we're in a different bank. So this is probably not the table we're looking for. So these are pointers for other data that just happen to have the same pointer information. So, all right, let's keep searching. Hit F3. Doesn't look like it's there. Not here. And you know what? I think this is it. Seeing a lot of things in the C4 area. We got the C3 here, C4, C4, C4. So we're seeing a lot of information in the same area. It indicates to me it's the pointer table. So this one's already pointing at C3, C4. And we know that our cell and item is currently pointing at AF, C4. So let's change it to C3, C4 and see what we get. Save that. Reload. And we've got to have people in our party to do any shopping. And what we want to look for is the cell text. And there we have it. We've repointed it to poop. So let's go ahead and, instead of having it pointing at that second one, let's have both of those pointers pointing at the AFC4. We'll change this to AFC4 and this one to AFC4. And if we had any others around here that were also pointing at either of those, we could repoint them. Or as you're going through debugging the game, if you come across anything that's pointing to the wrong area, you can search for the text and repoint it in the same manner. So we'll save that, go back down to our text. So we're going to go to 944AF, is where the sell an item text is at. Now we're only going to be using this first one, so we can zero out the rest of this. 0, 0, oh, wrong side. 0, 0, 0, 0, 0, 0, 0. Just fill it until we get to the next block of text. See, now look at all that free space that we have. Now we can use this for our new expanded menu. Okay, so since we were out of room for cell, let's go ahead and put cell right here. After the end text block here, we'll just type in cell. Save that. And let's find the pointer for this. And our offset, let's convert our offset to Super Nintendo low ROM 944 BD. So we are still in C4, but we need to change it to BD for that second pointer. We're just a little bit down from where we want to be. Here we are. Now let's locate our pointer. Now I'm a little bit used to being able to bookmark things, and as far as I know, you can't bookmark in HXD, and it comes in handy in Hex Workshop if you've ever used that. You can actually select blocks of data and then label them and go back to them really quickly. So I really like that. It helps. You can keep all your stuff in one location without having to refer back to your notes all the time. But in this case, we're just using notes. So the second pointer is after our second screen offset information. Second line down, second tile over. It's pointing to C7, C6. And we need to change that to, and it's actually different than I don't know what I was thinking before, but it is C6. So we'll need to change that to C4 and BD. So now, without changing anything else, let's save it and see if our cell pops up. And it will. But do that real quickly. Oh, now we have the full buy and sell. Now the next thing we want to change is the identify. I think I know where we can get our extra byte for that. This extra byte that we freed up for our cell. Actually, there's 2 bytes that we freed up, the S and the end string. So let's just move uncurse to here. Put our null byte there. We can type in full identify. And we freed up space so that we can actually put a space between pool and gold. So let's go ahead and do that. Pool. Now, buy is probably not what we want it to say there. We want it to say leave. but we don't have enough room right here. So what I'm going to do, I'm going to leave that right there for now. We have to remember that we still have to repoint all of this text. So uncurse needs to be repointed in our pointer table. So let's look at our third pointer. So first pointer, second pointer, third pointer. It's a CA C6. What is our new address? It's a C8 C6. And if you couldn't tell, I'm looking down at the offset down here. I don't have to do a full conversion to tell, because that last byte is always going to be the same between the two addresses. So we'll need to change that to C8. The next one, identify, is D0. Find our next one. D2 right now. Change it to D0. Pool gold. Now D9. Right now it is DA. So D9. All right. So this next one, we're going to use that free space, or that space that we freed up above, to write the rest of this. And we'll just, we actually just want to write the word done. So let's go up there and put the word done up there. And we're going to put it right after cell. So this is the space that we freed up before. And we have room enough to use it for other things as well. But we're just going to put done right here. Figure out where the pointer is at there. 944C2. Let's just put it in here for kicks and giggles. And we're going to change that pointer to C2, C4. Down here. That last pointer. Is here. Change that to C2, C4. Sorry if I'm going a little bit too slow for some people. Hopefully I'm going slow enough that people who are new to this can figure out what's going on. And we'll save that. Now let's go ahead and, just without changing anything else, reload our ROM. Start the game. Again. All right. So looks like we've been successful. We're able to repoint the data exactly where we need it to be. And now you see that it isn't as hard as you thought it was. Or maybe it's harder than you thought it was. Hopefully you learned something from this. Just real quick, I noticed that we still have by right here. And just so we don't use that for anything, or in case we want to use that for anything in the future, I like to zero it out. So that is done. And we have a more complete looking menu, a better localization, better translation. So we'll leave it at that. If you have any questions, leave it in the comments. If you'd like to see me do any other different types of changes to ROMs or anything concerning hacking, let me know, and I'll try to feature something. And take care.